Alright guys, so today what we're going to do is talk about our slope. We're going to talk about different kinds of slope. Slope is just generally a measure of how steep or not steep a line is, and can either be positive, negative, zero, or what we call undefined. So we have these four kinds of slope. If it moves up and to the right, as x increases, y increases, it is a positive slope. It means that the numerator and the denominator of this slope, when represented as a fraction, will both be the same sign. Now, this slope going downwards, so as x increases, y decreases, we have a negative slope. A horizontal line is a zero slope. You can just put the number 0. One key factor to remember is that for a zero slope, the y values are always the same. So there's the same y value. And then our last kind of slope is a vertical line. This is called an undefined slope. And that is because your x values are the same. And you'll notice that when we do the formula, when the x values do not change, it means we are dividing by 0. And if you divide by 0, then you get an undefined answer. So what I'm going to do is I'm going to go ahead and go over how to use the graph first, and then we're going to use ordered pairs. So what we're going to do is write our equation. And I'm going to use my equation tool. So slope is represented by the letter m. Many of you in the slope survey told me that what you could remember was the y equals mx plus b, and this is the m in that equation. In a graph, we will use rise over run. And in case you forget, rise is going to be our up and down motion. Because let's say you were told everybody rise, it's going to be everyone stand up. And run is our left and right motion. And again, if you were just running along the ground, you wouldn't be jumping up in the air. All right, so next we're going to go ahead and look at some examples. Number 1, we went from A to B. And we're always going to go from left to right to make it simpler. If you know how to do it going either direction, you're allowed to, but you need to make sure you recognize that this is a positive slope. The easiest way to do that is to start at the furthest left point and travel upwards or downwards to get to the right point. So for A to B, I need to go up first and then to the right. Now, the important question here is how far up did I go? 1, 2, 3, 4 units up. That is how far up. So m equals, and to do the fraction bar, I am just using the slash key. All right, so we went up 4 units, and now we're going to go 1, 2. Let me do this a little bit differently. Here we go. 1, 2, 3, 4, 5 units to the right. So when we move 5 units to the right, we have 4 units up. That means our slope of this line is going to be 4 over 5. And what you can also do is remind yourself by putting a plus 4 and a plus 5. Okay, let's go ahead and look at number 2. You can see where I accidentally left a note from earlier. Again, we're going to go from P to Q. So first I need to go down, and it looks like I'm going 1, 2, 3 units down. So let's go ahead and put that in there. M is, we went down 3 units, put minus 3. And then let's go ahead and see how far right we need to move. 1, 2, 3, 4, 5, 6. So we went 6 units to the right, so that's plus 6. And 3 over 6 is going to be simplified to negative 1 over 2, or you can put negative 0.5. I generally will represent slope as a fraction unless it's money or it's given to me as a decimal. Either way, it is up to you. Now, number 3 is a specific kind of slope that we've already seen. This is an undefined slope. We don't have to do any counting. And same thing for number 4. We do not have to do any counting here. We can just say that m equals 0. So now what do we do if we're given 2 points? Well, we have a formula to use. So m is equal to, and we're going to use our first Greek letters today. We're going to use delta y over delta x. Delta in this case is basically the Greek letter D, and we're using it for difference or change. But it essentially means the y2 minus y1 is divided by x2 minus x1. You may use either version of the formula, whichever way works better for you. I will use them interchangeably as I go. All right, so we have find the slope of line AB, which is A to negative 2, 5, and B is at 6, negative 1. So again, as usual, we're going to start by listing our givens. And that means I need to choose an x1 and an y1. Again, I'm going to use the point that is the furthest to the right, or sorry, to the left, or the one they give me first. So in this instance, they gave me point A first. So I'm going to use point A as my point 1. So my x1 is negative 2, and my y1 is positive 5. Therefore, my x2 is going to be 6, and my y2 is going to be negative 1. And what I'm going to be doing right now is boxing each of these sets in a different color so that we can see that when we write our equation, they do end up vertically aligned. Oh, not red and green. Let's do red, green, and orange. All right. So we're going to go ahead and put in our formula. So slope is equal to the difference in y's. And it doesn't matter which point is 1 and which point is 2, as long as you're consistent. What I mean by that is if you used point A for point 1, you always use point A for point 1 as long as you're doing that problem. All right, so let's substitute in what we know. Our y2 is negative 1 minus our y1, which is 5. And then we have our x2, which is 6. And our x1, which is negative 2. Now again, if you look here, you can see that I have my y2s are vertically aligned, and my my point 1s are vertically aligned as well. Okay. Now we can just run this through a calculator. It will give us a fraction, so I guess that would be a good idea to show you. But if we do this, we get negative 1 minus 6, or sorry, negative 1 minus 5, which is negative 6. And then we get 6 minus negative 2, which is 8. And that's going to simplify to negative 3 over 4. So I'm going to go ahead and just run this through the calculator to show you. Now what I get is negative 0.75. But if you click this right here, this circle, it will convert it to a fraction for you or back to a decimal as needed. So keep in mind that that feature is there for you. You can also use that feature to simplify fractions. So we have 3 over 6, we get 0.5, we simplify it to 1/2. Okay. All right, next one, find the slope of line RS. Now you may notice on your copy of the notes, there is a problem on my copy that does not exist. That's because I accidentally deleted it and I didn't put it back. You are not required to copy that one. All right, so let's go ahead and list our givens. Find the slope of line RS. Given, oops. All right, We are given that r is -7, -3. And again, because it's just given to me first, I'm going to make that 0.1. So x1 is going to be -7. Y1 is going to be -3. And then we have our x2, which is going to be 0. And our y2, which is going to be -3. Then we're going to substitute this information into our formula. Lowercase m, sorry, is going to be equal to y2 minus y1 over x2 minus x1. All right. And then we're going to go ahead and substitute in our known values. So y2 is -3. And we're going to subtract y1, which is also -3. And then we get x2, which is 0, minus x1, which is -7. And because -3 minus -3 is 0, okay, double negative is a positive, we get 0 divided by 7, and therefore the slope of this line is 0. And we can see that they have the same y value, so really we didn't have to do any math. If they have the same y value, the slope will always be 0. Now that we've discussed slope in a more general sense, let's go ahead and discuss how we're going to use it in this class. So first of all, we're going to discuss parallel and perpendicular lines. So we have parallel lines are lines that never meet, they never intersect, and they have the same slope with different y-intercepts. So if you were to run it through the Desmos calculator or any other graphing calculator, the two lines would overlap. If the two lines overlap, then they're the same line. Otherwise, they have the same slope and different y-intercepts. They are parallel. If you have two perpendicular lines or multiple perpendicular lines, they are lines that intersect at a 90-degree angle. Okay, they always intersect at 90 degrees. Now, what that means is that their slopes are what we call opposite reciprocals. They will also be called negative reciprocals. So we have negative reciprocals or opposite. Opposite reciprocals have opposite signs, and the fraction is flipped. So if we look here at number 1, we have 3/4. If I give it the opposite sign, it becomes negative, and I'm going to flip it, and so it becomes 4/3. Number 2 is 2. We need to remember that every whole number has a denominator of 1, or every integer has a denominator of 1. So we're going to change the sign and flip the fraction, so that becomes 1/2. Anytime you have an integer, it's 1 over the integer is the reciprocal. -7/8 becomes 8/7. Now 1/1 becomes -1/1 or -1. 1 is the only number in which both the original slope and the opposite reciprocal are going to be the same, or going to be integers. Otherwise, it's usually another rational number. And 0/1, if we flip that, it becomes undefined. Because again, we cannot divide by 0. So undefined. So we're going to use that information to determine if the lines are parallel, perpendicular, or neither. Now, this is going to be a little bit difficult to show my givens, so it's going to take a few moments. And I'll do everything in a couple different colors. So first of all, number 1, I'm going to say this is my given for AB. And again, I'm just going to use A is x1. And that's going to be -2. And then I'm going to say positive 3 is going to be my y1. And then we have x2. And I'm using point B as as point 2 for this case. And so we have y2, and that's going to be 6. Real quick, I'm going to go ahead and color code. I'm using AB is going to be green. And now we're going to go ahead and do our formula and substitution. So the slope is equal to, and in this case, I am just going to use the delta y over delta x. So change in y over change in x. I'm going to make this a little bigger. This is one of the benefits of using Kami. You can use a small font and then make it very large. All right. So we have our y2, which is 6, minus y1, which is 3, over our x2, which is going to be 2, minus our x1, which is negative 2. And we have 6 minus 3 is going to be 3, and 2 minus negative 2 will be positive 4. I'll put that down here. So the slope of line AB is 3 over 4. And then I'm going to go ahead and do my givens for the other line. Pick a darker orange. Our givens. This is going to be for line CD. And we're going to have our x1 will be negative 1. And our y1 will be 0. And our x2 will be 3. And our y2 will also conveniently be 3. So we've made our list. Let's go ahead and do our substitution. Let me change color. So our slope is going to be equal to our change in y over our change in x. And that's going to be equal to our y2, which is 3, minus y1, which is going to be 0, over our x2, which is also 3, minus our x1, which is negative 1. And we can run that information through. So we're going to go ahead and get that we get 3 minus 0, which is 3, and 3 minus negative 1, which is 4. And I'm going to go ahead and label this CD. And this one. And since these two lines have the same slope based on our calculations, we can say with pretty confident that these are parallel lines. And remember, the symbol for parallel is the two double lines straight up and down, and it looks this. Here we go. Moving along to number 2, we're going to go ahead and list our givens. And again, we're going to use AB. So this is going to be the given for AB. And then we're going to use x1 is going to be A. Or 0.1 will be A, so x1 is 0. And 0.2 is going to be B. So y1 will be 2. x2 is going to be 5. And y2 is going to be 4. So we have that information. Now we're going to go ahead and substitute in our known values. And I'm going to try and do a vertical this time for spacing. So slope is equal to, and this way I can do y2 minus y1 over x2 minus x1. And then I'm going to say that the slope of AB is going to be 4, which is our y2, minus y1, which is 2. And then we have x2, which is 5, minus x1, which is 0. 4 minus 2 is 2. 5 minus 0 is 5. So that indicates that the slope of line AB is going to be 2 over 5. Moving right along. We make our list of givens for CD. Starting with our point 1, which will be C. So x1 is going to be 1. And y1 is going to be 8. x2 is going to be 3. And y2 will also be 3. And we already wrote the formula this time, so we're going to go ahead and just skip to the substitution. So the slope of CD will be equal to the difference between my y's. So my y2 is 3 minus my y1, which is 8, over my x2, which is also 3, minus x1, which is 1. And when we simplify that, we can say that 3 minus 8 is negative 5, and 3 minus 1 is 2. So the slope of CD is going to be negative 5 over 2. And because these are flipped fractions and the signs are the same, we can say that these lines are perpendicular lines. All right, we're going to do number 3, and then we'll stop there. I'm not going to do number 4 as well, just one more. All right, you can see here I've gone ahead and listed my givens for segment AB. What I'm going to do now is go ahead and run that information through the formula. So we're going to say that the slope is going to be equal to, again, the difference in y over x. So that's y2 minus y1 minus x2 minus x1. So the slope of line AB is going to be 6 minus 8. And then that's going to be over 2 minus negative 1. 6 minus 8 is going to be negative 2. Oops. And 2 minus negative 1 is going to be positive 3. So the slope of line AB is going to be negative 2 over 3. Generally speaking, putting the negative out in front is usually a good idea. Now let's go ahead and do the same thing for line CD. All right, again, instead of wasting your time having you watch me make a list of givens for the 3rd or 4th time today, I went ahead and did that already. So I put my point 1 is going to be C, and I chose point 2 to be D. So that means we have our slope, and we already have our formula, so we can do our substitution. So we have our y2, which is 3, minus our y1, which is 2. And then we have our x2, which is 3, and our x1, which is -1. And when we simplify that, we can get that m is going to be equal to, and this is the m of segment or line CD. Three minus 2 is 1. 3 minus -1 is 4. And so the slope of line CD is going to be 1/4. And so in that case, that indicates to us that these lines are neither parallel nor perpendicular. Now, any difference in the slope means they are not parallel. And if they are not opposite reciprocals, they are not perpendicular. So if our example number 2, if we had had 2/5 and 5/2, they would not have been perpendicular because they would have been the same sign. They have to be different signs and the fractions must be flipped. Otherwise, the answer is neither. So that's all I have for you today. Make sure you get your notes filled out and turned in as soon as possible. And I'll see you later. Be safe. Bye.